get started, I would like to introduce KYZEN's own Ram Wissel.
Thank you, Chelsea. And good morning, good afternoon, good evening for everyone joining today. The topic today is about soil management and specifically about oil and metal finishing type applications. There's a lot of content, so we're going to jump right in. But the first question is often, well, why does it matter? And the typical cleaning process you see designated by that orange line here, where its solution starts out clean, but you start to build up several percent of soil or contamination, oil residues, interferes with your cleaning, and so then you change out the bath. You stop your process and you change that out, and that pattern starts to repeat. So over a month, you get a sort of this sawtooth pattern. If you with oil management strategies, you don't keep the bath 100% clean, but you can keep it, so your soil load stays at about 1%. So you have a nice consistent process with much less downtime. So how do we accomplish that? And successful cleaning really starts with the dirt or understanding the soil. And so we might say, well, what type of soil do I have, or what type of oil do I have? And that's really important to understand. On the left-hand side here, we have a typical hydrocarbon, or sometimes referred to as a straight oil. And on the right-hand side, the milky solution is more of a water-soluble coolant. And you might say, well, Ram, why is that important? And it's well because that type of soil dictates the management and filtration strategy. And I like this image because here we have water and oil, and much like your Italian salad dressing at home, we know that those don't mix. You shake it up, and eventually it separates back out. Those are immiscible types of liquids, and so that separation is fairly easy, and we'll talk about that. You can also create an emulsion, and these water-soluble coolants tend to become very stable emulsifying materials. And so in the picture here on the left, you see that oil start to separate out. And a true emulsion, that never separates. And so you have to have a different strategy for that. And so, splitting versus emulsifying oils or materials is really important. And there was a great tech to tech topic just a couple weeks ago back on May 13th. Today, we're going to focus on the management strategies, but if you want a little more information on that, I'd encourage you to go back and download or find that video. KYZEN's cleaning agents are designed to remove both the water-soluble, those emulsified materials, as well as the straight or water-insoluble type materials. And so here, we start off with the straight oils at the top, and typically you would use an oil or water separator, sometimes called a coalescer. They may have a skimmer, and the picture of the tank here, it's a pretty simple type machine for this coalescer. The water soluble coolants, because you can't, because they're not going to separate naturally, you typically have to use some sort of ultrafiltration or other membrane filtration. And when you look at the picture here, it's a much larger skid, bigger pumps, a whole array of membranes or filters here. And so it's a different scale and size, both in physical space and also in cost. So we look at just the water oil separators. Just in principle, you have your oily water mix come in, and then you have a large tank which allows it to just gravity separate out. The lighter oils float to the top. That can be skimmed off, and then the water, there's typically a weir that the water would pass under, and then the clean water would separate out. So it utilizes the insolubility of the oil. These are really simple, efficient designs that generally have no moving parts, and they're really sized by the volume for the residence time for that oil to physically separate. The next slide here shows a picture of, sometimes they'll have these plates, coalescing plates inside that to help those little oil globules or droplets actually adhere to that surface and separate out faster. So you don't need as big of a tank. You have more surface area for those oils to collect on. And again, these typically start in the $6,000 to $10,000 range for an effective coalescer. We also mentioned skimmers, and I like this image because what it shows is you might see a belt skimmer or a disc skimmer, but the principle is that the surface goes deep into the water, into the cleaning tank, and then as it lifts out, it picks up the oil, and then there's sort of a scraper, and you can see on the disc skimmer here, the scraper there. And what it does is it helps pull that oil off that surface and allows it to be collected and separated off from the tank. There's also floating and fixed type skimmers. And in this, you can see the two stainless steel floats, and it floats in the surface and helps you maintain that at just the right operating level, the fluid level to siphon off or to skim off that oil that's on the surface. Here's a picture of the skimmer set at a fixed height in the tank. This is a picture of kind of the whole complete process, and it shows you how these pieces work together. You have the floating skimmer with the oil right on the surface. That's going to allow it to pull the oil off, and then it comes over through this pump, pumps up into the coalescer, and you get that gravity separation where your captured oils come off and can be disposed of, and that clean or recycled water and cleaning solution, cleaning agent can go back in and be reused. And that's how, again, we start to avoid that jagged sawtooth pattern, but you have that nice consistent cleaning process. So Graham, you might say, well, what does it look like? And so what you have here on the left picture is you can see that the gross oily residue material contamination on the surface, and the skimmer, the lip here is above the solution. So it's not actually skimming that off right now. And the picture on the right-hand side, and that cleaning agent solution looks a lot better. It looks kind of like your what you would expect. And so that solution is skimming right off the top. And again, it's okay if you get some of the cleaning solution there, because that's going to go back to the coalescer and get returned as fresh solution or clean solution. So what if we talk about, the other side, the water soluble coolants, those emulsified materials? And here you have more limited options because these stable emulsions will not gravity separate over time. They really require some sort of membrane purification system. And again, the picture here shows a much larger system by the series of membranes, larger tanks and pumps. But in principle, the way the membranes work is you have that oily mix come in, and through the membrane, the cleaning agent in the water is able to permeate or come out through the outside, but it keeps the oily residue or the concentrate on the inside. So much like an RO system, you have a permeate or a clean water stream, and then the concentrate side. And so to look at that a little bit differently, using the term micro and ultrafiltration, if you think about just the standard water or cleaning agent coming in, may have a filter, something like a 10 micron filter for particulates, chips, fines, that type of thing. Microfiltration really takes you down to about 0.1 microns. Ultrafiltration goes another degree, and it's about down to about 0.02 microns. And that's really where you start to get organic and macromolecules, those oils and droplets and those emulsified materials out. Still may have some dissolved salts. And again, that's if you were doing reverse osmosis, that would be another set over here. But really for cleaning up those emulsified and water soluble coolants, the ultrafiltration or sometimes microfiltration will get you into that right range. So when we look at kind of a summary table here, it starts with understanding the soil. Is it a non-emulsifying or an oil splitting material or an emulsifying type water soluble coolant? If you have that splitting type material, almost all of the machines have some sort of coalescer or overflow skimmer. And the overflow skimmers can be start at just a few $100s. And for a reasonable cost, you can have the entire package. That type of system generally extends your bath life from just a few days up to 2 to 3 weeks, depending on your production level and how many shifts. For the emulsifying agents or those water soluble coolants, that microfiltration or ultrafiltration can be much more expensive to implement. If you don't have that system, your bath life may only be a few days. And again, you're in that sawtooth pattern. But for those that make that investment and are trying to manage that oil load, they can also have several week bath life. So if I look at this, kind of in summary, managing your soil is good for you because it ensures consistent cleaning processes. It minimizes downtime and reduces your chemical costs because you're not throwing out that cleaning solution all the time. The other thing is it's really good for the environment. It reduces your waste volume. It can simplify the disposal, And recycling water in the cleaning solution allows it as just a greener process. So with that, I thank you for attending. And Chelsea, do we have any questions?
All right, thank you very much. If you would like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.